Hello everyone, today I am presenting my machine learning project titled Sales Prediction using Multiple Linear Regression. The objective of this project is to predict sales revenue based on advertising expenditure on different media channels, such as TV and radio and newspaper. We use the advertising data set which contains 200 reports and 4 numerical categories. TV advertising budget, radio advertising budget, newspaper advertising budget sales, where sales is the target variable while TV, radio and newspaper are independent variables. Task 1. Importing all the required libraries. First, we imported the required Python libraries, Pandas and NumPy for data handling, Matplotlib and Seaborn for visualization, Scikit-learn for building the machine learning model. This library helps us to perform data analysis, visualization, and prediction. Step 2. Task. Task 2. Load the data. Next, we loaded the advertising dataset into Pandas dataset. We check data shape, data types, missing values, per few data. This step helps us to understand the structure and quality of dataset before performing analysis. Task 3. Exploratory data analysis. In this step, we explore the relationship between advertising channels and sales. We created scatter points, pair points, correlation heat map. From the visualization, we observed that TV and radio advertising have a stronger positive relationship with sales. Newspaper advertising shows a weaker relationship compared to TV and radio. The Bitman helps us to identify which variables are strongly correlated with sales. Therefore, build a multiple linear regression model. After data exploration, we build a multiple linear regression model. The model learns the relationship between advertising expenditures and sales. The regression equation obtained sales equals to 3.168 plus 0.0445 into TV plus 0.1949 into radio minus 0.0054 into newspaper. From the coefficients we observe, TV advertising territory affects sales. Radio advertising has a stronger positive impact on sales. Newspaper advertising contributes very little to expenditures. Step 5. Feature selection. Feature selection. Next, we perform feature selection. We created multiple modes using different combinations of features. TV only, TV and radio and newspaper. We compare their R-square score. This helps us identify which feature contribute most to prediction accuracy. The analysis shows that TV and radio are the most important predictors of sales. Step 6. Model evaluation using train test split. We then split the data set into training data and testing data. The model was trained on the training set and tested on unseen data. Evaluation matrices used were RMSE, root mean square error, R-square, 4. Results obtained RMSE equals to 1.65 and R-square score equal to 0.885. This means that the model explains approximately 88.25% of the variation in field, indicating good predictive performance. Task 7. Model diagnosis. To check model performance, we analyze residuals. We created residual distribution plots, residual scatter plots. The residuals were randomly distributed around 0, which indicates that the model fits the data reasonably well and does not show major prediction bias. Task 8. Interaction effect. In the final step, we created an interaction feature between TV and radio advertising. The purpose was to study the combined effect of these two advertising channels. After adding the interaction feature, the model performance improved significantly. The interaction model achieved R-square score equal to 0.9726. This means that the model can explain approximately 97.26% of variation in the sales. This result shows that TV and radio advertising work together and create a strong impact on sales prediction. We successfully developed a multiple linear regression model to predict sales using advertising expenditure. Key findings are TV and radio advertising strongly influences sales. Newspaper advertising has comparatively less impact. The basic regression model achieved on R-square score of 88.25%. Adding the interaction effect, we proved the R-square score to 97.26%. Therefore, machine learning can be effectively used to support marketing and advertising decisions by predicting sales more accurately. Thank you.